Good afternoon, everyone. We are approaching the beginning of our webinar, and it seems like we still have a healthy dose of people entering the call, which is good. We're sitting at around currently 121 participants at this time. Still waiting on some more, but that is looking good so far. That the numbers keep increasing. So just hang in there, and we'll begin our webinar shortly.
Okay, well, I'd like us to begin. Welcome, everyone, to the EMDQ, the Environmental Monitoring and Data Quality webinar for data validation guidelines. As many of you who are attending probably know, we have been having these webinars to make up for the fact that we had to cancel our EMDQ workshop, obviously due to COVID-19. This is the third in the series. The first was a general overview. The second was on PFAS. Both those webinars are actually available to watch. They've been recorded, as this one's being recorded. And obviously this one's on data validation guidelines that the EDQW has been working on. And so I want to thank all of you for attending and once again welcome you to the webinar. You'll hear me say this again, but these webinars, the feedback we've gotten have been very, very positive, and we really appreciate everyone's participation. And attendance. And at the end of this webinar, there'll be a survey form. And so I implore you to fill that out and send it to us. We review those very, very carefully. And that's how we have obviously set the topics for the upcoming webinars. And so we would really welcome your feedback. And so that would be terrific if you guys can do so. And so today's webinar, obviously, my name is Jordan Adelson. I'm the chair of the DoD's Environmental Data Quality Work Group. And we're the ones who put on this webinar, and so I'm welcoming you here today. After the welcome, Melinda McClellan, who works for the Army Corps of Engineers, will be providing an introduction, laying out sort of each individual presentation. Then Andrea Sampson, who also works for the Corps, will be going through the DoD General Data Quality Validation, the DoD General Data Validation Guidelines, sort of discussing them. And then following Andrea's presentation, we have two presentations that will go through some examples. We'll have Allison Seuss talk through a PFAS data validation example with a false positive. And then we'll have Pamela Hamlet and Nancy Wells talk through a PFAS example for data validation where it's a false negative. And then following on to that, we've got Christina Rink, who's going to be looking into both the DoD and non-DoD validation process. And then once that last presentation finishes, there'll be an open forum for us to ask, you guys to ask and answer questions. And so just a little functionality background for the webinar itself. So please utilize the chat functionality for technical issues only, right, related to WebEx. Any questions you have regarding the presentations shall be submitted via the Q&A function. So all the video and audio for the attendees is turned off. So that's the only way to submit questions, and we really do would love your questions. We want you to provide them. Each session, each one of those presentations has time allotted for you guys to ask questions. If we can't get to those questions in that individual session, we'll bring them up in the open forum, and if we don't address them throughout the webinar, we'll actually address them at a later time and send them out to all attendees. The presenters may choose to use polling feature. In fact, that was one of the things that when we get feedback, people really appreciate the polling feature, so you'll see the polling feature used in some of the presentation. And Matt said this at the top, and I sort of alluded to this, but this presentation is being recorded, so it can be watched at a later date, and just for your information so you guys are aware. When submitting questions during the session, in using the Q&A, please select the drop-down box within the Q&A panel and select all panelists. This will sort of help us be able to go through and obviously prompt the presenters with the questions, at the end, and sort of handle it and carry it on that way. And then finally, when the webinar ends, you'll be sort of prompted to be redirected to this Google form for our survey. Sometimes that gets blocked depending on your firewall and how your system is set up, but we'll be emailing a link to that as well out to all the attendees. Like I said, we find that to be sort of a critical piece of putting these on. The other thing I was going to mention is that this, we're planning on this to be the last EMDQ webinar for the year, for the calendar year. But once again, please provide us feedback. We plan on doing these more. Like I said, they've been very successful, and we'd like you guys to sort of help us figure out what the next topic should be. And with that, Matt, I want to turn it over to Melinda for the introduction.
Sure, thanks, Jordan.
Flipping over to your slides, Melinda, and you can take it away.
Okay. Well, as Jordan said, my name is Melinda McClellan. I'm a chemist with the Army Corps of Engineers, and I want to give you a little bit of an introduction to our data review and management subgroup, tell you what we've been working on, and then we're going to need your feedback a little bit to help direct some of our future efforts. So the structure of our work group, we have our chair is Brian Jordan with the Army. I am the co-chair, and we have 9 representatives from the Army, the Navy, and the Air Force. We meet once per week to discuss data validation and data usability primarily. The major projects we've been working on, I'm sure all of you are aware of the data validation modules. So we review these on an annual basis, and our plan is to ask for public comment about every 5 years on those. Of course, if questions come in or concerns, we'll take those into consideration as they come in. So currently published, there are the general guidelines, Module 1, which is GC Mass Spec, Module 2, which is ICP-OES, Module 3 is PFAS, and coming up, we're going to have Module 4, which is GC. We're currently in the final stages of review with that module, and we anticipate publishing it. At this point, it's going to be November, because there's only 2 days left in October. Module 5 is probably going to be ICP-MS, and we're going to start working on that immediately after Module 4. And in fact, there has been some work going on that already, but the real push for that is going to start after Module 4. So you can look for those coming up. So here's where we need your input. We need to know what the needs are that are out there for validation guidelines. So in a minute, I'm going to start at this poll, and I'm going to ask you to pick your top 3. Now, we generated this list based upon what B tables are in the QSM and what methods we see frequently being used. So they include LC and HPLC, AA, IC, perchlorate, dioxin, GCMS in air, which is distinct from the GCMS that was already published, which focused on 8260 and 8270. Also TOC, cyanide, hexavalent chromium, and radiochemistry. Now, obviously, we recognize that tables B16 through B20 that deal with radiochemistry, those methods can be very different from one another, and so this would probably be multiple guidelines. It wouldn't be one solid one, but we've kind of grouped them together here for the sake of making this list a little bit shorter. So again, I want you to pick your top 3, and I'm going to open that poll now. So what we're trying to figure out here is, we've asked around in our group about what we think the needs are, but we really want some of your feedback. We want to know what guidelines would help you guys out. So I'm going to give about a minute on that poll. Just a few seconds left. Okay, so let's see if I can share these results here. I don't know if you guys are able to see that or not, but it looks like a lot of people are interested in the LC and HPLC. We've also got quite a few responses asking for GCMS in air. So that's, and some IC. So that's great to know, hexavalent chromium. I appreciate everybody taking the time to do that, and we will certainly take that into consideration. If there's anything on this list that you think is really important that we don't have, you can feel free to reach out about that and let us know. The other major projects our group works on are the data usability guidelines. So those are currently in development, and hopefully we're hoping to get those out in 2021 sometime, but that's going to be similar to what you see with the data validation, that it's just going to give some guidelines on how we think data usability should be conducted. And then also, where we can, we try to do training and outreach, such as this webinar. Upcoming events, just so you guys can have your eyes out for them. The Data Validation Module 4, like I said, we anticipate that being November of 2020. Data Usability Guidelines sometime in 2021. And although we're not entirely sure about the exact time frame, the next ICP-MS Data Validation Module is probably going to be 2021. So with that, I'm going to roll into our first presentation. That's going to be Andrea Sansom, who is going to cover the DoD General Data Validation Guidelines. So environmental chemistry subject matter expert Andrea Sansom is currently a USACE Omaha District project chemist working as a technical lead for federal clients on projects from BRAC to FUDs with chemical concerns from PFAS to TCE and from site investigations to remedial site closures. She has a background of 10 years in environmental laboratory settings, 15 years as a private sector consultant, and she's been with the USACE for 5 years. Her career expands over several areas of expertise, from sampling, analysis of samples, validating data, and project reporting. Andrea is passionate about helping her clients gather environmental data to support her decisions. So Matthew, if you can make sure that Andrea can control her slides, that would be great.
Thank you for
Andrea, you should be presenter.
Thank you for that introduction, Linda. So the EMDQ has undertaken the task of developing data validation guidelines, and I participate in that subgroup. I'd like to thank the EMDQ for sponsoring this event. And I will be including polls for audience participation, and you should see the first poll come up shortly. I'm not being able to go to the next slide, Matthew.
Sorry about that. That was my fault. It should be.
Thank you for the poll, and let's see. I'm still not able to go to the next slide, sorry. Thank you. So the general guidelines are an overview of the vision EMDQ has for data validation, being a process of documenting quality and limitations of data. It all started with the general data validation guidelines that are currently at revision 1 and published in September of 2019. And the individual modules roll out from the basis of the general validation guidelines. And as Melinda covered, we have 3 modules currently published. The general guidelines describe acceptable validation at the party as being independent from the laboratory, and were conceived for federal projects that comply with the QSM and tend to use SW846 methods, or in the case of PFAS, method criteria objectives that were developed by EMDQ. Separate modules have been published, and the basis is for the DoD QSM Appendix B tables for the QC check parameters, frequency, and acceptance criteria, along with appropriate corrective actions. Let's see, slide 3, please. So, now if you've closed the poll, right, I'm looking at majority of the audience having more than 5 years of experience working in a laboratory setting, which is awesome. You're going to love today's webinars. Okay, so why do we need another validation guideline? The industry had a gap between the existing guidance and use on our federal projects that follow a UFP-QAP as a living document that defines the project-specific needs for data. ELAP accreditation is based on the DoD QSM requirements that include additional oversight that is not within EPA and state accreditation. And DoD projects have flexible expectations between screening level data and definitive data, where the level of effort is set to the level of confidence the project team requires to make decisions. The deliverables provided by the laboratory can follow the same validation level of effort demands. Go to slide 4. Thank you for the new poll. Before these guidelines, the default used by third-party validators tended to be the National Functional Guidelines, which were written for the Superfund sector and are specific for methods published in the Contract Laboratory Program Statement of Work. Let's look at some differences between 3 method parameters. We're going to compare the National Functional Guidelines for organic CLP methods and Module 1 that covers DoD QSM Table B4, Organics by GCMS. The green highlights CLP methods, and the blue shows the DoD QSM requirements. The first example is ICAL, or initial calibration. The CLP has individual minimum relative response factors for each analyte of a set of target compound lists called TCL lists. In comparison to that, our projects have variable target compound lists, and the DoD QSM defers to the method requirements that are being used. For response factors, that may be a short list of target analytes sensitive to instrument operating performance called System Performance Check Compounds, or SPCCs. The next difference we'll look at is surrogates. The list and number of surrogate compounds added to monitor extraction performance varies between the CLP and our program. Even how the recoveries are associated to target analytes is different. One SVOC surrogate out, but greater than 10%, does not necessitate qualification for us. We would need 2 out of 3 base neutral surrogates outside of recovery limits to warrant qualification of all base neutral target analytes. In comparison, the latest CLP NFG associates acid surrogates with base neutral target analytes, which is not in compliance with the methods that we use. And thirdly, the CLP has removed the requirement for laboratory control spike from semi-volatile organics. On the other hand, the DoD QSM requires a laboratory control spike for all methods and that have a batch preparation procedure. There will be more on the use and application included in the last presentation today from Christina Rank of LBC. Matthew, did we close the poll?
Yes, the poll should be closed, and you should see the results for the UFP QAP question.
Awesome, so most do include. And we'll go to slide 5. One of the best outcomes from these guidelines has been the published definitions. The terms Stage 1, Stage 2A, Stage 2B, Stage 3, and Stage 4 have replaced Level 2, Level 3, and Level 4, which are terms used by the industry but not readily defined. The stages were defined in the EPA guidance for labeling externally validated laboratory analytical data for Superfund use in 2009. They actually came up with these stage references, and they have been incorporated into Appendix A of the QSM. So we're going to go to the next slide. Thanks. The list of materials to include can be found within the data validation guidelines. Stage 1 is the minimal deliverable, and each progressive stage incorporates the previous with additional content. Stage 1 has the field investigative sample summary forms and field QC like field blanks and field duplicates. Stage 2 incorporates the laboratory preparation batch QC summary forms. Stage 3 adds in instrument quantitation forms like raw data necessary to recalculate sample results and instrument standards. And finally, Stage 4 includes chromatograms and spectra necessary to qualitatively evaluate those results. Next slide, please. With the published definitions, scope of work to contractors and flow down to subcontractors have referenceable expectations for the level of effort. The UFP QAP with respect to project objectives can outline 100% at a Stage 3 or 90% Stage 2 and 10% Stage 4. That is defined within the UFP QAP and is different for all of our projects. However, the definitions for what is included in each of those stages is in this guidance. If the concentrations reported are critical for your project, then this Stage 3 definition allows for manual re-quantification. Next slide, please. Labeling has been standardized to identify a process used for subsets of data within database. 10 years from now, a new project will be able to evaluate secondary source data for new project objectives because of this unifying labeling system. Typically, I see Stage 2B VEM because we have automated systems that validate our data to a point, and a person has to finish doing a Stage 2B normally. So I typically see S2B VEM on my data. Next slide, please. Data validation is a process that concludes with the application of qualifiers with respect to measurement quality objectives defined in each UFP QAP. All DoD data qualifiers acceptable for use are published with these set definitions. Biases are denoted with the plus and the minus. Let's see if I can do that. Here and here are the plus and the minuses. And note that the R or reject flag has been removed because the validation does not determine if the project goals have been met. Neither does the validation report provide the decisions to be made based on the data set. The project team should use the appraisal of the validation along with their own judgment when making decisions, which includes whether or not to accept or reject the data during the data usability stage. The data usability process should be described in the UFP QAP on worksheet number 37. And as Melissa mentioned earlier, we are in the process of creating data usability guidance. So in conclusion, I'd just like to say that these validation modules remove the subjective interpretation for consistent and comparable work products that becomes something reproducible over time. And with that, I will return the floor back over to Matthew Lloyd.
Thank you very much, Andrea. At this point, we will be accepting questions. You can make sure to try and use that Q&A feature. It'll make it easier for us to keep track of all the questions and responses and ensure that we capture everything that's asked. So here we have a question here that you may be able to answer, or this may be something for Brian Jordan. Do validators only need to be independent of the lab and not the samplers?
I'm sorry, would Brian like to answer that? As far as the definition is defined, it does not call out whether a sampler is qualified to do the validation or not, but yes, they are independent of the laboratory.
Yeah, so sorry, I was on double secret mute here, so I will jump in. I had mute on my phone and mute in the webinar, but so this gets back to what is identified in your QAP as to at what level your validation is happening. So if you need a third-party validation, that may need to be independent of the prime. That should be defined in your QAP. So it depends on where you're getting your validation done and how that's defined by your project needs.
Perfect. Thank you very much. We have a question here. Why is the DoD creating a data qualifier as an X flag? This isn't a valid data identifier, an EPA cert.
So I brought up the reasons why we didn't want to put the rejection of data on the shoulders of a data validator who may be third party and not privy to the project team's objectives for that data set.
Correct. I would just piggyback onto that decision as to whether or not a particular data element can be used for decision making needs to be, in the view of DoD, needs to be the project team, not just, particularly if the validator is not seeing the full scope of what the project decision is, it's very difficult for them to make that assessment. They can look at the criteria that was established in the QAP for quality control, and make the assessment to X flag something, but ultimately it's a project team decision to look at the root cause look at any other corrective actions, and then make a decision as to whether or not to use a piece of information. So that's why we hang the X flag on it, and then it's up to the project teams to ultimately make the decision to either reject the piece of information or to put some qualifier on it to document its uncertainty.
Thank you for that response. We have a question here. Is there a data validation checklist that can be shared?
The modules do incorporate appendices with examples.
Individual, and I would just add on that individual programs within DoD may have also checklists that they can supply to you. The one that I'm very familiar with in the FUDS program, we do have a checklist, a template of a checklist that is a good starting place. I would not say that for every project, it is the exact same. So each project needs to assess to what level, because again, that gets to do you need level 2A review? Do you need 2B review? Or do you need level 4 review? It really comes down to the project decisions you're making and what checklists you may want to apply to your data.
Perfect. Thank you very much for those responses. At this time, we'll have to move to the next presentation. Thank you very much, Andrea. Melinda, you want to go ahead and introduce our next speaker?
I would love to, Matthew. Our next speaker is Allison Cease. Dr. Allison Cease is a chemist with the Seattle District of the U.S. Army Corps of Engineers. She works on environmental remediation projects, including sediment, in situ treatments, and treatments of PFAS in drinking water. She received her BS in chemistry from the University of North Carolina at Chapel Hill and her PhD from the University of Wisconsin-Madison. Her background includes research in chemical reaction kinetics and fluoropolymer materials. And she previously worked for the chemistry laboratory at the Puget Sound Naval Shipyard in Bremerton, Washington. Dr. Cease is going to talk to us about the DoD PFAS validation guidelines with a potential false positive example. Thank you, Dr. Cease.
Hey, thank you, Melinda. Great. Well, welcome, and thank you, everyone, for attending. We really appreciate it, and we hope this will be useful. So I want to go to my overview slide, which is my next slide here. It should be showing slide number 2. But I also have a poll question up. So we could go ahead and start that with, say a 1-minute time limit or so. And so that poll question is, are you currently comfortable looking at raw data for PFAS analysis, such as chromatograms or ion ratios? And we'd love to get a sense of, how people feel about looking at this kind of stuff, because we will very shortly. And while you're answering that poll question, just the overview of this presentation. So I'll touch really briefly on the data validation guidelines for PFAS, and then I'll give you a little background on 2 key concepts that I'm going to use during this presentation, so the ion ratio and retention times. And we're going to kind of look at those in more detail with first a real positive example for a PFAS detection, and then a PFAS detection that's a potential false positive example. And we don't, of course, have the final answer of if it's a false positive or not, but it's something that likely looks like it could be. And then, determining that for sure takes some further analysis, so we can talk about that as well. And just please note that, the data that I'm sharing, I've cut it out and from different sources, and it's all anonymous. And so the purpose of this presentation is for education, of course. And then we'll talk a little bit about QC that would vary for samples of different concentration, like a high concentration AFFF sample or a lower concentration groundwater sample. And then we'll just wrap up the presentation. Okay, great. So it looks like we're kind of divided, but for the poll question, but more people are on the no side of are you currently comfortable looking at raw data? So after the second presentation by Pamela Hamlet and Nancy Wells, well, I think we'll have a follow-up question that says, do you feel more comfortable? So think about that as we go through our presentations. Okay, so on the next slide, which is slide 3, I just wanted to give you the links and just briefly touch on the data validation guidelines. The EDQW released Module 3 for PFAS in May of this year. And so this is a great resource for understanding more about this analysis. And I also have the link for the most recent version of the QSM on this slide as well. And so my goal with this presentation is that, we always have a kind of a varied audience, from people who are doing analyses in the lab every day to more on the project management side and everywhere in between. So what I'm hoping is that this will be useful to everyone and kind of teach everyone a little bit about what you would be want to looking at, what you would want to look at with the data. Okay, so the first concept is the ion transition. And so this is a really fun and cool part of LC-MS. So I've shown, a drawing for PFAS here. And what we're interested in for purposes of the MS-MS is looking at the sulfonate form with a mass to charge ratio of 499 M to Z over here on the right. And so what we're doing with the LC-MS is we're making a parent ion, and then we're also breaking it into fragments and looking at those fragments. We compare the ratio of 2 fragments for our analysis. And so we have both a quantitative transformation and a conformation transformation that we look at in the DoD. And so for PFAS specifically, we're looking at the 499 to 80 M to Z transition as the quantitative transition. And this is breaking the sulfonate molecule down into an SO3 group. And then to confirm, we're looking at the 499 to 99 M to Z transition. And so that's a fluorosulfonate group that's coming off. And so PFAS is just an interesting example to all of us because it turns out there's actually some natural products that have the same molecular weight as PFAS despite not having fluorines, which is pretty interesting that nature makes a sulfonic acid, at least one, so it has the same 499 to 80 transition. And there's other possible interference as well. So even though we do have these 2 ion transitions to look at, we want to look at them carefully and use them to help us consider our data. And you can find this information in the data validation guidelines, so I've copied some of it out of there. So we can just kind of briefly, though, discuss. So the calculation of the ion ratio, basically this ion ratio, you can see in the equation IR, is the ratio of the quantitative ion abundance to the conformation ion abundance. So like we just discussed on the previous slide, the ratio of the 499 to 80 transition divided by the 499 to 99 transition. And then we can also think about percent recovery. So a known ion ratio versus a reported ion ratio. And the criteria you can also find in both the QSM and the data validation guidelines. For the ion ratio, we want the ion ratio of the sample to be within 50 to 150% of the ion ratio of a standard. All right, we're on the next slide, which is slide 6. So this one I want to touch on the concept of retention time, kind of the other important concept to keep in mind for these examples. So the first bullet here is retention time of the analyte and the extracted internal standard analyte must fall within 0.4 minutes of basically another standard from a different run. So basically a standard that would be a daily calibration verification or maybe the midpoint standard of the ICAL. So this is comparing 2 different runs. Basically in one run you have your analyte and your extracted internal analyte. Sorry, extracted internal standard analyte. You're comparing that to a standard. The next bullet point is a 0.1 minute requirement. So this is actually for within the same run an analyte and the labeled analog pair. So basically your extracted internal standard in this case would be, say, a carbon-13 version of PFAS. And so within your same run there for that sample, you should see your PFAS and your labeled PFAS eluting within 0.1 minutes of each other. All right, so I want to go into the real positive example, and then we'll look at the potential false positive example. And we're also going to encounter a poll question here. I'll explain it a little bit first before we put it up. You also may want to get out a calculator or your phone or an Excel spreadsheet, or perhaps you now remember how to do long division after watching a child's Zoom class for school. But you might also find this information directly on the slide. So just prepare yourself for that just here in a few seconds. But so here we're looking at some data that's cut from a laboratory report. And this would be once you start scrolling down past just the initial kind of reported detections, further into your stage 4 laboratory report. So your report, you should be able to find retention times, an expected ion ratio, and a sample ion ratio. So here, we have the first few lines of text. You see it says D29, but then it says 13C4 PFAS. So that's our carbon-13 labeled PFAS internal standard. And then the next few lines, that's data for our PFAS itself. So you can see the ion transitions, the 499 to 80 on one line, and then 499 to 99 on the next line. You see retention times under the RT column. We have responses and ratio. So Matthew, if you could put up the poll question now. So the poll question is, what is the ion ratio of this data as well as the ion ratio of the standard? And so some of you may have the answer already just by looking at the report, or some of you may be pulling out your calculators. So the ion ratio of the data you can both find on the slide as well as you can calculate it yourself. The ion ratio of the standard you can find on the slide. So let's give it about a minute or so. And Matthew, you can let me know when it looks like it's a good time to close the poll by responses. All right, it looks like the poll is ended. I don't see the responses yet. There we go. Thank you, Matthew. So let me go to my next slide here. Wow, you guys are great. And I really appreciate everyone who took time to think about this more and answer the poll. This is really wonderful. So this slide has some answers on it a little bit. So the ion ratio you can calculate, as I've shown kind of in the middle section here, dividing these response numbers by each other to get to 3.97. Or very helpfully, this report has the 3.97 ratio, as well as the 50 to 150% acceptance range, the target there of 4.01 being the standards ion ratio. And another thing is that the retention times of 4.418 and 4.418 for both the carbon-13 PFAS as well as the PFAS are within 0.1 minutes of each other. So this looks really good. I also want to show you the chromatogram because in case you're having trouble finding these numbers, or you want to look at what your chromatograms are actually looking like in more detail. You can also do a kind of quick estimate of the ion ratio using the intensities of the peaks that you see. So I have two chromatograms here, and these are from this sample. And so on the left, you see the 499 to 80 transition. On the right, you see the 499 to 99 transition. And so from the peak heights, basically the top of the peaks, I've drawn a red arrow that's pointing towards the left, towards the x-axis, and I've kind of circled basically the rough intercept of that on the y-axis. So you see on the left, that peak height is about 9, and then on the right, that peak height is about 30. You can see I've also, though, circled the multipliers on the y-axis. So this is our second poll question. Matthew, if you could put it up for about a minute. The question is, what are the rough intensities of each peak? So use the red arrow and use the y-axis, and also pay attention to the multipliers on the y-axis, particularly when there's large numbers of zeros strung together. This is always a little difficult. So let's give about a minute for that one as well, though Matthew, feel free to close it when it looks like people are mostly responding. Hey, this is really great. Thank you for so many people who responded, especially since we have, people from all, kind of levels here. I really appreciate everyone taking more time to look at these chromatograms. So I'm going to my next slide, which is slide 10, and it just gives you the answer, which most people selected. So it's just a little bit of, a little bit tricky to both keep in mind any sort of multipliers that might be on the y-axis, as well as what your peak height actually looks like on the y-axis. And, it's just so you don't have super long numbers running off and everything is nicely compressed on your lab report. But certainly, turning your head to the side and looking at all those zeros, it's something that can be a little bit difficult. So it's a great thing to keep in mind when you're doing a quick check of your ion ratio and looking at your raw data. That set that we just looked at, that's on the right-hand side of this side of this slide now. So that's the sample with the 499 to 80 transition, the 499 to 99 transition, and the rough ion ratio of around 3 that you all have calculated by dividing basically 900,000 by 300,000. And so on the left is a standard from the same batch, and it's looking really similar too. So over on the very far left for the standard, you see the 499 to 80 transition. Kind of follow the red arrow over, and it hits about 80 on the y-axis. Use the multiplier of 1,000 to get 80,000 as the peak height. And then on the right of the standard side of the slide, the 499 to 99 transition, you're following that red arrow over to, let's say, around 22, somewhere between 20 and 24. And it has the same multiplier this time, 1,000. So you're dividing those 80,000 by 22,000 and getting 3.6 roughly. So the ion ratios of your standard, 3.63, and your sample, which is 3, are within 50 to 150% of each other, which is great. So that was a real positive example. Let's look at the potential false positive example, and you'll be able to see that some things look really different here. So what I want you to look at first is kind of the text report that you'll get. And so the first few lines of this are for PFAS. You see the 499 to 80 transition and the 499 to 99 transition. And then the next line is the internal standard, that's the carbon-13 labeled PFAS. So under the RT column, you have the retention time of your PFAS and your labeled PFAS. You do have a response column as well where you could calculate the ion ratio, or you could look at the ion ratio under the ratio parentheses limits column in this particular report. So Matthew, let's put up the poll questions now. These are divided into two. So the first one asks you to look at the retention time. Is the retention time of PFAS and its labeled analog within plus or minus 0.1 minutes? And then is the ion ratio within 50 to 150% of the target standard? So we'll let that run for about a minute or so, and Matthew, of course, feel free to close it early if people have mostly answered. Okay, great. Thank you, everyone, for your answers. So I'm going to the next slide, which is 13, which we can look at for the answers. So under the RT column for retention times, you see the retention time of the PFAS and the labeled analog are not within 0.1 minutes of each other. Most of you said this as well, which is great. And then we could either calculate the ion ratio of 0.27, or we could see that it's nicely listed in this laboratory report, 0.27, with an acceptance range listed based on the target standard. And so the ion ratio 0.27 that we get is outside of the 50 to 150% range of the target. So here we see two failures. We see a failure both in the retention time, at least between the PFAS and labeled PFAS in the same run, and we see a failure in the ion ratio. I want to give you a comparison of a standard from the same batch. It looks quite a bit better. So here, looking under the retention time column, the retention time of the PFAS, 3.731 minutes, is within 0.1 minutes of the labeled analog, which is at 3.740 minutes. The ion ratio here between the standard and this other particular standard that I've pulled out is, well, the ion ratio, this standard is 4, and then the other particular standard was 4.32. So they're both within 50 to 150% of each other. So we see that our standards, kind of in the same batch, are looking good and like each other, but it's our sample that was sticking out. There's a note that actually the standard and the sample actually did have retention times that agreed within 0.41 minutes. So if you were just looking at that, that one would have passed, but it was the kind of internal labeled PFAS and the PFAS that disagreed by the 0.1 minutes requirement. Okay, and I also want to give you an opportunity, now that you know how to do this so well, or maybe you did already, but to look at the chromatograms for these. So on the left, we have the standard that we just looked at on the previous slide. And so you see on the far left, the 499 to 80 transition, and then over to the right on the standard side, the 499 to 99 transition. Here you could also do your quick check of the peak height compared to, the y-axis, looking at that. And so you would get, say, if you chose around 8,000 and around 1,900, you would get an ion ratio of roughly around 4.2. And you see here, it looks, the standard looks nice. It looks like our other PFAS peaks that we looked at earlier. So the initial peak that comes off first is the branched PFAS, and then the larger intensity peak is the linear PFAS. So that's looking just like it should be. They're eluting in order. Our retention time is based off the highest peak there. And that looks good. And so it looks like, our standard includes both the branched and linear PFAS as we want it to do if our, potential analyte would have both branched and linear forms. And then over on the right, we have our actual sample, and this is the one with the failing ion ratio. And so just we would get the same kind of thing if we did the quick check based on the peak heights. So the 499 to 80 transition, you might kind of estimate this as around 11,000 for peak height, and then you might estimate the 499 to 99 transition around, say, 59,000 for peak height. And so that's around 0.19. I believe the actual result was 0.27. And so, either way with this quick check as well that we're doing, the sample ion ratio is not within 50 to 150% of the standard ratio. You can also see that the peak kind of looks a little different. So we don't have this kind of nice same shape of the branched peak that's smaller coming off first and then the higher linear peak. And so we might talk a little bit more about this as far as reasons for things that, could be a false positive, or maybe you have an actual positive, but an interferent making it look like a false positive. So basically, when you see things that look kind of different, it's definitely a possibility you could have some interferent causing broadening or shouldering, something unusual could be going on. So it's a good thing to kind of be able to look at your chromatograms too. And this might be an example of just, having someone else look at it for you, maybe starting to look at it yourself and seeing something, is a little weird. It depends on obviously what level and your role in the particular project. But I think it's good for all of us to be able to look at this at least a little bit. Okay, so the next slide here is what do you actually do when you think that your data is a false positive? And this is kind of a longer question, or at least a question that has a longer answer, and sometimes no clear answer. This slide also has a little more text than I normally include, but just I wanted it to be a good reference for you later in this, kind of virtual telework environment. But so if you look in the module 3, an analyte with a failing ion ratio would be flagged a J, not automatically rejected. So while we think this is a false positive, we're not totally sure. And there's some kind of things to consider first. So, one, the first bullet point there is perhaps the standard did not include branched isomers and the sample did. So in this case, that could be the source of the problem. We think that's not the problem for this data, though, because when we looked at our standard, we saw that nice little peak of the branched and then the larger peak of the linear isomer. Another option for samples potentially is that the sample could have a much higher concentration of the branched isomer compared to your standard. And this could be due to environmental fate and transport or transformation in the environment. The environmental samples we look at may not always have the same ratio of branched to linear as when they were, first produced by like the electrochemical fluorination process or, what is available in the standards that we can purchase. Another thing to consider is the third bullet point. So you could have your analyte and an interferent present in that retention time window that you're looking at, and a high concentration of the interferent could mask the presence of an analyte. So in that case, you could still have a positive for PFAS, just perhaps at a lower true concentration. And so you wouldn't want to, necessarily write it off as a false positive without doing further investigation. But this would definitely be a project team discussion and kind of discussion. So that kind of goes in, to what to do next. So the data validation module recommends that a full evaluation, which would be a stage 4 data validation, would be necessary after something like this. And that's because you want someone to really scrutinize your raw data and the calculations that were done. And then I would also just recommend, discussions with your project team. So this could be part of your data usability assessment. Discussions with the laboratory, of course, as the people actually looking at this data. If you're not, looking at, working in the lab yourself, but from a project team perspective. And discussion with experts you might be able to reach out to through your professional networks or through your organization. Okay, so a few wrap-up slides. I want to give you a few more pieces of information. So a good thing would be to specify your data needs upfront in contracts. And just because PFAS is such an important analysis right now, or PFAS analysis is important, and also very complicated and, new to many of us, though obviously all of our expertise is growing together, at some rate or another as kind of, our understanding proceeds. But a typical recommendation, it'd be great to always receive the stage 4 lab report. And that would mean that anyone could look at the chromatogram, at any time once you have it on your project team. And then data validation, a typical recommendation that I'm seeing is that you would have all of your data validated to stage 2B, and then you'd have an additional 10% of each data package validated to stage 4. And so this is just a recommendation. It's definitely not a hard and fast rule. It's just something that I've been seeing more recently. But the stage 2B, of course, will cover both the sample QC and the instrumental QC, and then, a smattering of stage 4 to kind of look more closely. Of course, if you do see something that had a potential false positive, your module recommends that you would get that particular sample validated to stage 4. And then 2 slides on different matrices. So this is something that's really good to keep in mind as well, as this field is a learning process for all of us. But we can have really different matrices for aqueous samples. And so how do you prepare for this? That's this slide. So what I mean by different matrices in aqueous samples is you could have really high concentration samples like a AFFF formulation, or you could have relatively low concentration samples such as groundwater that's contaminated with PFAS. Solid phase extraction, SPE, must be used unless the samples are known to be this high PFAS concentration. So for example, if you know you're sampling AFFF, then you would start diverting from this process. But by default, everything should use solid phase extraction. For SPE, you'd want to use the entire sample bottle plus the rinsate. And then what do you do, though, if you're looking at a high PFAS concentration sample like AFFF? Here, instead of SPE, you would use serial dilution. You also need documented project approval for samples prepared by serial dilution as opposed to SPE. So, sometimes we're not totally sure what our sample matrix will be. It's not always a clear-cut case of, oh, I know I'm sampling a groundwater well, or I know I'm sampling an AFFF solution. Sometimes you have things in between where you're not really sure. And this is where your project team and your lab really need to work together to discuss the best way to analyze these samples based on the lab's expertise, based on accreditations, based on what the project team knows, and then to have all of this documented. Okay, so, and then, once you kind of know what you're doing, you definitely want to pay attention to how the QC varies for the different matrices. So you'll find these in the DoD QSM, and you'll find kind of the ramifications of them talked about in the Data Validation Guidelines, Module 3. But for a low concentration sample, you need to have NV-carb or equivalent used on sample and batch QC sample. This is a cleanup step. And you need a matrix spike and matrix spike duplicate. And, many of us work with groundwater samples primarily, so by now this may seem pretty obvious. And, it kind of depends on the types of projects you're doing and your roles. Not everybody works with high concentration samples as much, so those actually have a different set of QC. So for high concentration samples, such as AFFF or something that could fall into a similar category, something that you have to analyze by dilution instead of by solid phase extraction. Each field sample, you have to prepare it in duplicate. So this is basically a matrix duplicate. You need to do serial dilutions until you achieve the lowest possible limit of quantitation for each analyte. And then, again, for number 3, the bullet point here, that matrix duplicate is required, but actually the MS-MSD is not required. And then another special QC is you need to do a post-spike sample for samples that have a reported value of below the limit of quantitation for any analyte that you're interested in. And so by that, you can kind of understand matrix effects. You don't want to say that you can't see something if it's just a matrix. So how do we help control for that? So we have the matrix duplicate as well as the post-spike sample here. And those are maybe a little more unusual if you're mostly looking at groundwater samples. So I think it's a really good thing to keep in mind as we look at PFAS analysis. Okay, so I want to go through some conclusions, and then we can also do questions and answers if there are any. So for conclusions, I want to talk about how ion ratio and retention times, they're key indicators of a real positive detection versus a false positive. But as we talked about, a sample where these fail may still be a real positive. And this is why the modules, the data validation guideline modules recommended J flag for something with a failing ion ratio. And so, seeing these gets you on a path of needing, to understand your data further. At this point, you're still not sure, of what is actually the case. So, get your data is my second bullet point. So it's just a kind of like unofficial recommendation, or kind of something that I've noticed is that people are often requesting the stage 4 data package, and data validation 100% to stage 2B and 10% to stage 4 is pretty typical. But this is obviously a project team discussion based on your needs for data quality. And then my third bullet point, look at your data. You can do it. Some of you are doing this already, of course, because you're the ones analyzing the data. Some of you have never thought about looking at your data, but we've looked at some together today. So I'm hoping you might feel a little more comfortable in the future and at least have the tools to know what questions to ask or things to think about when you want to talk to your laboratory or your consultant or experts about the data. So QC samples for groundwater versus AFFF matrices are different. Plan appropriately. And like I said, this also, falls for those weird in-between samples where you're not actually sure what it qualifies as. It's not clearly groundwater or clearly AFFF, but it's something that you can't use SPE for, and you have to go to serial dilution. Make sure you use the QC samples that are appropriate for the high concentration samples. And then issues, we talked about this a little bit, but discuss with your project team, discuss with your laboratory, discuss with experts. Obviously, when you get data where you get some failing retention times or ion ratios, you're not really sure of, what your actual result is. And, kind of discussing this with these, key players can help you understand further why exactly the data looks that way, if anything can be done to get, a better resolution on the data. And other things like that. And so, just always keeping those avenues of communication open is something I'd really recommend. So let's see. With that, we're actually done with this presentation. I'd be happy to take the questions. Matthew, I'll turn it back over to you. And we do have some other PFAS experts on the line, and Pamela Hamlet and Nancy Wells and Brian Jordan, of course. So I'd be happy to have any of us answer the questions that come up.
Perfect. Thank you very much, Allison. We have some time for questions, so we'll address the ones that we don't get to during our open forum. So with that first question, how can one tell the difference between a false positive and interference caused by an IAR discrepancy?
I'm actually not sure.
IAR. IAR.
I may not be enough of an expert to get to the acronym here, but one thing that we did talk about was that you can definitely have interference kind of coming into the same retention time as your analyte of interest, kind of depending on your chromatographic run and some other things like that. So I would say for that. First of all, apologize, I don't know the actual acronym, but that definitely sounds like something to talk to your laboratory about or to experts about who can help you maybe get a better chromatographic resolution.
Thank you very much. We have this question here. Wouldn't any fluorinated sulfonate have the same 80 and 99 transitions?
So you can look in the QSM for the recommended quantitative transitions, and so these are selected based on responses for those particular analytes. So other people on the line might be able to weigh in more, but basically what was done was selecting a confirmation, a quantitative first, and then a confirmation ion that were the best for those particular analytes. So while, everything that's a sulfonic acid would, have at least some level of response from those sulfonic acid or fluorosulfonic acid components, the quantitative and the confirmation ions that were selected were done on, I believe, an individual basis for each analyte as what would be best in terms of response.
Thank you very much for that response. We have a question here. How do you folks feel about HRAM data, specifically QTOF?
Oh, this is interesting. So I don't know too much about this subject, but I was speaking with another member of the EDQW about QTOF recently, and so they actually had pointed out to me that in a sample where they had a potential false positive, they were able to work with an EPA laboratory to do high-resolution mass spec with the QTOF, the quadrupole time of flight analysis, which in their case gave them better resolution than the LC-MS data. For a particular problem to help them decide if there was a false positive, a real positive, or, interference plus your actual analyte, that kind of situation. So I think that while I don't have experience with that, and it's maybe not, obviously LC-MS according to our table B15 is our first line of analysis. I think it's definitely a possibility for more complicated samples.
Thank you very much for that response. At this time, we're going to move to our next presentation and circle back to the remaining questions during our open forum. Thank you very much, Allison, for your great presentation. With that, Melinda, would you like to introduce our next presenter?
I would love to. Our next presenter is going to be Pamela Hamlet. Pamela Hamlet is a chemist with the Air Force Civil Engineering Center. Her lab background includes more than 20 years of mass spec experience as a forensic chemist for an agency that investigated environmental crimes. This may explain her lively interest in legally defensible data. And collaborating with her is Nancy Wells, who is the newest chemist with the Air Force Civil Engineering Center. Her background is also in mass spectrometry. So they are going to talk today about a DoD PFAS validation guideline project, but a false negative example. So thank you to our presenters.
Thanks, Melinda. And I would like to thank Nancy, who is our newest chemist, because she contributed greatly to this presentation. All right, a little bit of background. The Air Force is monitoring private groundwater wells that are used for domestic drinking water sources in a situation where PFAS may have migrated off of an Air Force base. And we should have our first poll question. All right, the poll has ended. And actually, we count on the data usability assessment to be conducted to give us all of these advantages. And everybody got that right. So we'll continue with our background. For the quarterly monitoring wells, the Air Force is checking for any increases in wells that may require mitigation. And the following example that we're going to talk about comes from one of these routinely monitored wells. So there was a kind of expectation by the project team that the well was having contamination in line with historical data, somewhere greater than 35 nanograms per liter, but less than the HA, which is 70 nanograms per liter. So our example today, we're going to talk about PFOA. The data usability team was concerned when the final results were reported with PFOA as non-detect, because in our series we see that the sample was analyzed undiluted and reported as non-detect, but at a 5x dilution. They ran it at a dilution for another PFAS, and they came up with a result for PFOA at 52 nanograms per liter. So in a confusing reporting system, the laboratory reported 52 nanograms per liter in the summary table of detections, but reported non-detect in the results. So our stage 2B data validation rejected the 52 nanograms and reported it as non-detect. And so, like I said, the data usability team was very concerned because they had historical data that the reason we're monitoring this well is that we have contamination. So evaluation of the dilution summary and the reanalysis summary is required at stage 2A validation and at every higher stage of validation. So the project team came back with a request for a secondary review of the raw data in combination with the data validation. Here's our next poll question. Okay. Well, anyway, we think that when you're comparing an undiluted sample with a 5x dilution, we think those results should be similar to each other. In our example, the sample contamination was not extreme, and this comparison may not work with samples that have greater contamination, where the sample needs a dilution by orders of magnitude, but just for this example today. So this slide discusses the guidance from the DoD Data Validation Guidelines Module 3, which has instructions regarding contamination introduced through dilution water. In our example, the data package had different results reported in different sections. The undiluted result was non-detect, and the 5x dilution result is 52. Is it possible to verify contamination from dilution water? Well, we have to look at the raw data first. So here's the raw data for the original undiluted sample. There's the quant ion on the left and the qualifier ion or the confirmation ion on the right. And just a visual appraisal confirms that both peaks are there with adequate signal to noise and within the appropriate retention time window. So the quantifier ion is not integrated, which results in an automatic non-detect to be reported for PFOA. And it's unclear if the M in parentheses is for manual integration of the qualifier ion or for the removal of the quant ion. All right, here's a comparison of the undiluted sample on the left and the 5x dilution on the right. The undiluted sample reported as non-detect, and the 5x dilution was reported at greater than 1/2 the HA, which is consistent with the historical data. The PFOA did not come from the dilution water, since it appears in the raw data from the undiluted sample. So comparison of the target analytes in the undiluted and the 5x should have alerted the laboratory that their reporting was inconsistent between these two sample reports. So the next step is compare. Here's a side-by-side comparison of the quant ion response for the sample on the left and the LOQ on the right. So the sample response, just looking at the y-axis, which Allison went through with us earlier, we see there's just about a 10-fold higher response than the LOQ. So it's reasonable that the sample result should be above the LOQ in a reportable concentration. So the end result is that PFOA should have been reported from this undiluted analysis. And at this point, I would recommend that you consult your project point of contact for further direction, whether an amended report can be generated. But in the absence of an amended report, then the detection in the dilution could be reported since the response fell within the calibration curve. All right, I believe we have a poll question. Okay, I guess it's complete. So The answer should be at any stage of data validation 2A or above, they should have been able to identify this false negative because evaluation of the dilution summary and the reanalysis summary is required at stage 2A validation and at every higher stage of validation. All right, our lessons learned. When there are inconsistent results, it should prompt a deeper investigation by the data validator. Bullets 2 and 3 come directly from Module 3 of the Data Validation Guidelines. And errors, regarding errors, data validators are encouraged to reach out to their point of contact, the person identified in the project CLAP, such as the UFP CLAP worksheet number 6, when preparing the validation report. Ask for guidance on how best to proceed with detected errors and inconsistencies. And the data usability team plays a valuable part since they should have a big picture knowledge to inform their decisions. So I turn it back over to Matt.
Thank you very much, Pamela. At this moment, we will open it up to questions regarding this presentation, and I'm also going to open a poll that is going to kind of touch upon what Allison had stated. You know, do you feel more comfortable now following these presentations? And while we are answering those, please feel free to submit any questions into the Q&A field, and we will work to get those addressed. As of right now, it's looking good. Everyone seems to be more comfortable and more confident in looking at some data packages. Those results will be posted here in a second. And we have a few questions that have come in that I will share in just a moment. So those are our poll results. And now, all righty. So does DoD require all dilution to be reported?
I think it probably goes back to the CLAP.
All righty.
Matthew, I'd like to add, sorry, Matthew, I'd like to add to that question. I think what they're asking really is how did we compare the undiluted and the diluted PFAS, what is it, PFOA that we were looking at directly when a laboratory may have only reported the non-detect on a result form? Was it in the EDD? Was it on any summary form, or would the raw data need to be compared between the undiluted and diluted?
So, to be honest, I was called in after the fact. I was the one called in by the project usability team who said this doesn't seem right. So I really don't know what was originally reported. I was just called in to look at the raw data.
Right, and I'm thinking that in most cases, only the usable result would show up on a summary form. could be wrong, and it is up to the UFP Corp for sure to outline what gets reported.
Well, thank you for that discussion. We're going to move to our next question. But the data validators don't usually have the historical picture of the data set. They only look at the data report in front of them. So how would they be able to identify a situation like this?
So they would need to look at the summary of the dilution report, because there should be data associated with that. So they should be able to compare that there were results reported from the 5X dilution and no results reported from the undiluted.
Thank you very much. We have a question here. Was the dilution water analyzed and the results reported?
So we did not feel that we had to go back to the dilution water because we found that it was just, it appeared to be inadvertently hit. The hit was inadvertently missed in the undiluted sample, and it should have been originally reported. So we didn't have to take that next step and look at the dilution water.
Thank you. We have a question here regarding the matrix. Is SPE applicable to all types of water matrices, even if there may be solids?
So it is the QSM requirement that all aqueous samples be prepared using SPE.
Thank you. And then we have a question here. Is there a designated qualifier flag for a false positive or false negative? Or is this a case for an X flag?
Well, I think, like I said in my presentation, it's time to contact your point of contact and say, what can we do? We have an inconsistency or an error. Can we resolve it before we get to an X flag?
Thank you. All right.
Matthew, if you're talking, I think we may have lost your audio.
I was talking. It's because I muted myself. So I apologize for that. So at this time, I believe that concludes our Q&A, and we will move to our next presentation with Christina Ring. Melinda, do you want to go ahead and introduce?
Wait, hang on. Before we do that, we're a little ahead of schedule. Do we want to take just a quick 10-minute break? Give people a chance and then to step back from their computer for a bit. Jordan, you okay with that? All our presenters, you okay with that? Anybody negative with that?
Sorry, Brian, I was on double secret mute like you were earlier. Yes, I think a 10-minute break makes complete sense.
All right, so I'll throw a timer up here really quick and share my screen. And we'll go on a 10-minute break.
You are presenter now, Brian.
Okay. Everybody should see my email. And then I'm starting the timer. We're on a 10-minute break, guys. Come back in 10 minutes.
Brian, do you have a copy of the agenda? Maybe we could put that up.
I do. That is a good call. Let me go. Yeah, I do. I believe I have the current version. I'll go put it up. I lied. Matthew, go ahead and email me. The one I have still does not have LDC. So if you want to email it to me really quick, we'll see how fast. We'll test how fast the email is, and I'll throw that agenda up. Or Jordan can send it. Somebody can send it to me.
7 minutes and counting.
7 minutes and counting. Thank you, Andrea.
That was under 2 minutes.
You notice how I stayed out of all the Q&A for the last 2 sessions. That would have definitely been a stump the chump moment right there. Allison, I had to mark no for I want to look at raw data. So in the last 2 minutes we have before the break is up, I would ask everybody, please stand up, do a few jumping jacks, get your brains working again, get your heart rate up over 140. Just kidding. You don't have to get your heart rate up. Christina's going to be very engaging, and she'll keep you very focused on DoD and non-DoD validation processes. So. All right, last 20 seconds before we get started. I will hand it back over to Melinda, and Melinda can introduce Christina. And we will get started again, and I'll hand, I guess, Matthew, you'll still back the screen. Okay.
Okay, welcome back, everybody. Our next presentation is going to be by Christina Rink. Christina Rink Ashdown has over 13 years combined in environmental laboratory and data validation experience. Her hands-on laboratory experience includes CLP and SW846 ICP-MS, ICP-OES, and CVAA analyses. She's a senior project manager as well as the senior inorganic and radiometric chemist for LDC. She performs validation for trace metals, radiochemistry, and wet chemistry for all major federal and commercial projects. She has worked under various DoD, DOE, CERCLA, and EPA data validation guidelines for the Navy, Army Corps, AFCEE, AFCEC, CERCLA, and commercial projects. Her presentation is titled A Look into DoD and Non-DoD Validation Processes. Thank you.
Thank you, Melinda. So today we're going to focus on similarities and the differences in the data validation and data management processes between the DoD and non-DoD projects. I'm going to start with discussing why validation is important, go into some differences between the DoD and non-DoD projects, touch on laboratory data deliverables, address usability, and then finish with some best management practices that can be applied to help with a successful project for both DoD and non-DoD work. So validation began as a process to assess data under the Superfund program, and it's expanded over the years to encompass a variety of methods for a variety of purposes. So we validate to get data of known quality that is reviewed against a project-specific document. Validators assign qualifiers that can be used as an aid in the usability assessment of the data. There are a few different approaches on how data can be validated. One approach is manually. This is when the chemist will review the data package, prepare a report, and then manually enter in the qualifiers into the EDD. A second process is completely electronic. This is when the chemist utilizes an automated data review tool, or ADR, to review the QC elements, and at the same time that the tool, the ADR, is reviewing, it will assign the qualifiers to the EDD. However, this is limited by the QC that is available in the EDD. A third option is a combination of the manual and the electronic. And during this process, the chemist will utilize the ADR tool, so it'll review the QC and the EDD and assign the qualifiers, and then the chemist will review the data package for the supplemental elements, such as calibration, that is not included in the EDD, and then manually add those qualifiers into the EDD. I do want to just mention that laboratory and validation qualifiers are two completely different things. The laboratory qualifier, it does indicate a QC failure, but it may not be using the same limits that the validator is using. So the validator is using limits that are specific to this project. And the lab may be using their in-house SOP limits, so they can vary. Also, the qualifiers between laboratories can vary, and if you have a project that has multiple labs involved, the same qual may have different definitions between the different labs. Whereas with the validation qualifiers, we are using a specific set, and this will be defined in the validation document reference, whether it's a regional validation document or the DoD, or either way, it will be a specific set, and regardless of how many laboratories or how many methods are involved in the project, the same set's going to be used. The validation qualifiers also take into consideration the field QC. As the field QC is reported in the lab, the validation qualifiers will qualify data based off of it, such as your trip blank, your equipment blank. But it is worth noting that on the EDD side of this, the laboratory qualifiers are completely retained. There is a laboratory qualifier column in the EDD, and this is not touched. The validators will update the validation qualifier column. So Andrea did mention the qualifiers earlier, and so I'm not going to go into detail of them, but overall I just wanted to show that the NFG qualifiers and the DoD qualifiers are similar, with the exception of the R and the X. So let's take a little look at the X a little bit more. So the DoD General Validation Guidelines stated that it is not the role of data validation to accept or reject data. I actually like this. It takes a lot of pressure off of us. The X is not the final qualifier. The project team needs to come together and determine the final qualifier during the usability stage. And validation is not usability. And I'll come back to this point a little later. But when they're at this stage, this is a good time to bring the data validator back into the discussion. The data validator did qualify at X for a reason, so make sure to bring them back, maybe get their perspective on this, and then as a team decide on the final qualifier. And then it's also worth noting how I mentioned the EDD earlier, where there's a validation qualifier column. Well, the X is going to be assigned here, and it should stay here. It's the final qualifier that needs to be updated on the EDD side. So it should still reflect that the validator assigned an X. So when we start a validation project, the first thing we always look for is the clock or the SAP. This kind of sets us off. It starts us on what kind of project we're dealing with, what path we're going down. So for non-DoD projects, traditionally it's the National Functional Guidelines, NFG, that was always used, and this was designed for the Superfund use and intended for the CLP methods. Also, if there was any regional data validation guidelines, we implemented them as well, but most of them, by what I've seen, are pretty much based off the NFG. With DoD publishing several documents over the past few years, the validation has adjusted its process to ensure that the data intended for the DoD use adheres to its guidelines. So there was the DoD validation guidelines, and then soon after, the modules were published. And the modules are instrument-based and based on the QSM methods, and they're based on SW846, which is great, because before that, we were dealing with the NSG based for COP, so I was really glad to have a document actually referencing SW846. And if you look at the back of each of these modules, there's a comparison table at the end of the document, and it compares the method to the QSM criteria, and I just think that's kind of neat to look at. Like Melinda mentioned earlier, there are more modules coming. The GC is coming next month, it sounds like, and then the ICP-MS soon after, which as an inorganic chemist, I'm actually really looking forward to the ICP-MS coming out. All right, Andrea mentioned a few incidences earlier where there is differences between DoD and non-DoD. So I'm going to just elaborate on a few more examples. In my first example, I wanted to show an example where the QC criteria was different. So in this scenario, we're evaluating an ICAL RSD for method 8260. If this was a non-DoD project, we would use the 8260 method criteria, which is 20%. If this was a DoD project, we would be using the 8260 QSM criteria, which is 15%. So my second example is showing where the same outlier will actually have two different validation qualifiers applied. So the situation is you have a 6010D CCV failing high at 113%. If this was a non-DoD project, we would qualify the associated results that will detect as estimated with a high bias, and the non-detects will not get qualified. However, for DoD projects, we would qualify the associated detects and non-detects as X. So the data validation stages, levels, tiers, categories, there's a lot of terminology for this, and a lot of the terminology differs based on the region that is being validated and the regulator. And Andrea went through all of these very clearly earlier, so I'm not going to get into the details of each one of them, but the EPA did come out with the stages in 2009, which did help clarify because the levels were not very clearly defined before that point. And then the DoD adopted this stage terminology, and they clearly defined what is intended for each stage in the DoD validation guidelines. And that was great to have a document out just to clarify even more so what is expected with each level of validation. However, I do want to mention that stage 2A and 2B are intended to be a review of the summary forms only, and raw data is not intended to be reviewed in these stages. However, this can be kind of challenging, especially for stage 2B, because not every laboratory has the ability to create the summary forms or COP-like forms that are needed for every component of stage 2B validation. So this is when the team, the project manager, the consultant, the laboratory, the validator, at the beginning of the project, we need to get together and discuss this and make sure that the validator is very clear on what they need to validate and make sure the laboratory can deliver a data package that will encompass all the information needed. So if stage 2B, if we need some supplemental raw data to actually complete a stage 2B validation, that should be communicated at the beginning of the project so everybody's on the same page about what kind of deliverable is necessary. This is a busy slide. This has a lot going on. A lot of information in this slide. This is just a summary, and I'm only really wanting to focus on two things in this slide. The first is organic and inorganic validation do differ, and they do have different QC requirements. And the second is just to show that each stage of validation will actually build on the previous stage. Okay, I told you earlier we'd come back to data usability, so here we are. Data validation is not data usability. They are two separate things. Data validation is a tool that can be used during the usability assessment, but it is separate. Data validation focuses on the analytical data with respect to the project measurement quality objectives, whereas the data usability is the evaluation of the project as a whole. It encompasses the field plan, the sampling process, the historical data. It's the entire project. So they are two completely different aspects. And I just want to finish up with some management practices just to help projects go successfully through the validation steps. This can be applied to DoD or non-DoD projects. The first one is consistency. This is always key. Make sure throughout your crop that your worksheets make sense and line up, specifically worksheet 12 and 28. These should match. And then also, make sure you have the most up-to-date information when you're writing the crop and the most up-to-date references. And then know that these may change, especially if this is a long-term project. These probably will change, actually. So have that in mind and make a plan and have a plan on how to deal with this. So annually, the laboratory usually updates the reporting limits and sometimes even the spike limits. So if your crop's based off of laboratory limits, that could be an issue as well. Also know that the regulator may update screening levels. Sometimes validation documents will get updated and changed as well. So just kind of have a plan in place on how to deal with this as it evolves. And then contact your team, contact the laboratory and the validators and put them in contact with each other, kind of like I mentioned previously with the data deliverables. Make sure the laboratory is very clear on what deliverables are needed for the level of validation of the project. There is some information that is normally not included in the crops, and this just means we need to communicate a little bit more. Most of these questions need to be answered up front before the project begins, and one of them is about how to handle laboratory and field blank contamination. The National Functional Guidelines and the DoD do have two different approaches, and we just kind of got to figure out which approach we're going to use at the start of the project. Also, the field QC associations, we don't always know as a validator how this EB should be associated. So you're going to have to tell us that. We're going to need some of that information. The blind field dupes, we're going to need those pairs. And also for the field dupes, traditionally with NFG projects, the NFG does not address field duplicate qualification at all. So we used to have to always make sure, I guess we still do for non-DoD projects, confirm how you even want to handle the field duplicate. With the modules coming out, it did specify that you do qualify. So I'm glad that came out. It just clarified one more question that we have. But we also got to decide how we want to handle the low-level hits. Difference is a very common evaluation technique, or sometimes there's a threshold, meaning like you only want to qualify if both results are greater than the LOQ. So we just got to determine this at the beginning of the project. I've kind of mentioned this the last few slides, communication. I mean, that's really the key to a good project, successful project, regardless if it's a DoD or non-DoD. Make sure everybody's in the same loop, make sure the contractor, the lab, and the third-party validators are communicating. If things change, make sure we all know if the reporting limits change or if there's any change to the project. We just need to be on the same page. So open communication up front will help us throughout the entire project. And even at the end of the project, bring us back in, especially if there's the X qualifier maybe. Talk to your validator again on asking why they assigned the X and get maybe their opinion on that. So to finish up, the DoD and the non-DoD validation processes do follow method criteria, unless those variances that are specific in the QOP or validation document, such as I had the calibration instance example earlier. Overall, DoD and non-DoD qualifiers are similar with the exception of the R and the X. The DoD has released multiple documents over the past few years, and these are great. I think they overall lead to a more consistency among the validators. There is the SW846 based, which is great. That's actually the documents we're referencing. It just makes for an overall clearer project. And then also it clearly defined the stages. So that was great to see as well. And then overall, communication. Everything for a successful project, I think, goes back to communication. Thank you.
Perfect. Thank you very much for your great presentation. At this time, we will move to the Q&A section for questions for you specifically. We have the first question. Where can you find the comparison of DoD to non-DoD criteria for validation?
There is not a direct comparison that I know of. That was just me looking at the NFG and comparing it to the DoD.
Thank you very much. If QAP criteria are different from QSN, should we follow the QAP criteria?
Yes, the QAP is always the top of the hierarchy.
Thank you very much. We have a question here. How do you handle situations when the QAP is referencing an older version of the QSM, such as 5.1, but the laboratory is accredited to newer versions, such as 5.3?
This goes back to the communication. This is something the validator is held to the QAP. So if something is changed and it does change like that, we need to communicate. We need to discuss on how we want to handle this moving forward. And then also, it might be good, just a little tip, when you're writing the QAP, instead of referencing a particular 5.1, it might be beneficial to reference the DoD, and then at the bottom I've seen footnotes that just reference the newest one available.
Thank you very much. We have a question. What are the major differences between Stage 3 and Stage 4 laboratory deliverables?
The Stage 4 includes the chromatograms in the deliverable.
Hi, Matthew. This is Andrea. I would like to add on that. When the EPA guidance was written back in 2009, they were a team of people that were also working on a SAD deliverable that was transferable, freeware kind of were the keywords they were using. And when they defined Stage 3, they wanted to include calculations from initial calibration and continuing calibration and associate that with numbers that were reported for samples. And if you can imagine the next step with the industry moving forward in the future to be able to incorporate an image would be hard in an EDD. So that is why the stages were written that way. However, when we are looking at a PDF and doing our validation, it's hard for a laboratory to separate the difference between here's the numbers part of our chromat and here's the images part of our chromat. So typically, laboratories will provide the whole thing, even if validation stops at a stage 3. And stage 3, again, is just recalculating numbers. Stage 4 is qualitatively addressing images in manual integrations, for instance.
Thank you very much for that response. We have this question, and it may be more for the data validation subgroup. Where do you get the requirement for DoD to X-flag all results associated with a 6010D high bias, CCD?
Yeah. Oh.
I'm not sure I heard the whole question, but I do have an idea of why we are interested in false positives. We're interested in positive bias that might push us over a threshold that causes us to do remediation. And if the bias is 300% or 100% and our screening criteria is close to a reporting limit and the number that's reported is close to that screening criteria, the whole team needs to evaluate how that impacts decisions.
Thank you for that response. We have this question: have you ever seen an N flag used, and could you provide an example of when it would be used?
So with GCMS, you have to have your sample spectra match your standard spectra. So when that doesn't match, then it might call for presumptive qualification.
Historically, it's associated with tentatively identified compounds. It's a tentatively identified compound.
Thank you very much. We have a question here. How would you qualify if the SPE clogs and the entire sample and rinsate didn't go through the SPE? I'm assuming this is more specific to a PFAS validation.
Yeah, so for any samples in a batch that are processed together, for a validator to be able to properly, in the lab actually, for the lab to properly demonstrate accuracy and precision, the samples, the QC, they need to be batched consistently and processed correctly. There may be, with discussion with the contractor, there may be a need to qualify the data. Because one doesn't become a representative. One becomes excluded as a representative of the batch.
Yeah, I totally agree. And, you know, this might be kind of one of those situations where you have a sample that you were a little unsure of its concentration or its qualities or its matrix when you were sending it to the laboratory, you know, from a project team perspective. And so if, you know, you had planned and your laboratory had planned to be able to analyze it using SPE and, you know, using that associated QC types of criteria you would use with SPE only, but then it turns out that it clogs or you can't, and you have to use serial dilution instead. Just like you said, the communication is completely key, and in that case, you know, you would have to be using different types of QC samples that are appropriate for the serial dilution rather than the SPE.
I'd like to also add that, you know, if you're collecting surface waters, if you're collecting a groundwater that you couldn't stabilize the well when you were sampling, the turbidity was high, but it never went below 10, or your stability parameters weren't met, you're going to have higher content of dissolved solids or suspended solids. in the field, that should be something that's noted because, like Allison was mentioning, if it makes it to the lab with the one container that they tried to do the whole container and rinse it, and then they realize they can't do that, it might be too late because there isn't a backup container. So in the beginning, in the planning process, there could be historical data for the wells that indicate you're not going to be able to get a low turbidity sample or you're collecting the surface water. You should be contingency planning at that point. And when your field crew goes to the field, they should be looking for that situation that might happen so that you can collect additional volume if necessary. Potentially asking the laboratory to do centrifuge separations. You should look at this in the project planning phase, way before a validator is determining if they should apply an X flag.
And if it did end up getting through, if the data did end up getting reported through, then it's definitely something you'd want to look at data usability, because part of that data usability is lessons learned. So that just definitely be a lesson learned for the next event, because it looks like you're going to be doing another event, so you can collect the appropriate sample the correct way and process correctly.
Thank you all very much for your detailed response. We have a question here. Who has the final say in usability determination if an unreconcilable difference of opinions arises between the chemist and the rest of the team?
Not the chemist.
I don't know if Brian wanted to weigh in on that one. I mean, it definitely seems like a project team discussion, and it obviously depends on if the government is the head of the project, stakeholders, et cetera. Maybe Brian has some thoughts on that.
I'm sorry, I missed which question was it?
It's actually in my chat. So it was, who has the final say in the usability
that's why
determination?
I'm trying to read it. And I'm like, wait, I don't see this question. Go ahead and read it again. I'm sorry.
So who has the final say in the usability determination if an unreconcilable difference of opinions arises between the chemist and the rest of the team?
Yeah, I'm sorry. I should have jumped right in on this one. It's always, if you're talking about the Corps of Engineers, and I'll jump in with Corps, and I'll let the other services respond if they have a different opinion on this, but for the Corps of Engineers, it's always the project manager in consultation with their ultimate customer. So the Air Force may be their ultimate customer, but the project manager is the ruler of the roost. And I know the chemist, as Andrea jumped in when she said definitely not the chemist, because occasionally the chemist gets overruled because, look, there's just not time to go collect additional samples, and we're going to go with a J- or a J+, and we're going to use that data to make a decision. And the chemist put up their hand and said, yeah, I don't agree, but you're going to go ahead and do what you're going to do. And they're going to document that, and they're going to move forward after the data usability.
Thank you. And speaking of J- and J+, is there any guidance from DoD regarding the use of J only versus J- and J+?
We will let you do either. We don't give you any defined guidance. I know there was a question way early on that also addressed what happens when you have conflicting QC that would say you have a bias low and a bias high, and I answered in the text regarding that becomes part of that usability and that communication that needs to happen as far as how you apply the appropriate flag to the QC result. So you could have, I don't know that we're going to issue defined guidance that you always must apply the bias as well as the J flag. Anybody else want to jump in on that? Nope. Okay, next question.
All righty. Regarding the format of the data deliverables, does it matter if it is hard copy or electronic?
Completely up to, no, it doesn't matter. You could do everything paper if that's the world you live in, though I will tell you that there are few projects other than very small ones where we're taking a UST out of the ground and we're going to make a quick decision and decide that we're going to fill the hole. That may be able to be all handled in paper, but most of our projects that involve extensive analytical data, we're going to be asking for electronic deliverables, which makes it that much easier to handle some aspect of the review using automated data review tools. And certain programs will require you to use automated data review tools and extensive EDDs in order to meet the requirements of archiving their data. So I would point to ERPMs and FudgeChem as two good examples, and then the Navy's NIRIS database as well.
Thank you very much.
Yeah. That's NIRIS, Brian, you're correct. I was just confirming to Ryan it's NIRIS.
Perfect. All right, so this question is kind of more of a specific to the DoD ELAP program, but I guess it could affect projects, so it might be good information to share. What is the designated length of time laboratories have to obtain accreditation to a new version of the QSM in order to maintain their active status, their accreditation status?
So this is Jordan. I'll try to address that one, Matthew. So whenever we release a new version of the QSM, we have an implementation schedule associated with that that we coordinate with the accreditation bodies, and they communicate that schedule out to the laboratories for when and how long it will, what the implementation time is. Typically, we typically have a 2-year implementation cycle based on the fact that that's how long it takes for you to come around for your next on-site assessment.
Perfect. Thank you very much, Jordan. Could more info be provided about why non-detects would be flagged X when the bias on the CCV is high?
So this is Melinda McClellan. I believe that was part of Christina's presentation, so I might invite her to answer that question.
I believe Andrea actually addressed this a few comments
back. Was I misremembering?
I'm sitting here trying to open up the guidance to make sure what I'm going to say is accurate, but I believe we have X flags when on a non-detect only when the CCV is majorly out. And I can't open it up quick enough to check, but when you have a non-detect reported, as in the case that Pamela Hamlet presented, and you're talking about somebody's drinking water, I think you'll see that we need to be careful about when we're using non-detect data just as much as we need to be careful about when we're using positive data. that doesn't really, define everything in detail, but that's the thinking that we have. When we apply an X flag, it impacts the usability. Somebody needs to look at it as far as the project team is concerned and make a decision as to whether that non-detect is really usable or not.
And just to add on to what Andrea said, so remember the X flag is not a rejection of the data. It just calls into question and raises the spectrum of the data for the usability assessment to address. So because it's been flagged with an X doesn't mean it can't be used by the project. It just means the project needs to evaluate it.
Thank you very much for that response. We have a question here. Can you discuss the rationale for the new approach to retain laboratory dequalifiers for blank DV action or data validation actions? Are there other cases where DoD is looking to maintain lab qualifiers?
I'm not sure I understood the question, but I believe we've verified in ASED and in ERPMS and in NIRIS, there are separate fields for individual qualifying entities. So there's a field for the laboratory qualifier, and that stays there and never changes. And there's a field for the validation qualifier, which again stays there and never changes. And then there would be a project qualifier, the final one, a third field. So I'm not sure I'm understanding the question.
Yeah, that's no problem. That may be a question we have to address outside of this call to verify with the guidelines. Next question, for low-level detections less than the LOQ, data would be flagged estimated regardless by the lab and the validator. So why do we need to define the need otherwise in regards to the field duplicate?
This really is just a project decision. If you don't want them to be evaluated, if they're less than the LOQ, then that's fine. If you want them to be evaluated, we will. If they're out, sometimes those reason codes that we add to EDDs or in the validation report. And then in addition to it being less than LOQ, it may also be a field dupe, and especially if the comparison is between one hit less than the LOQ and maybe one hit greater than the LOQ. So this really just goes back to how the project's set up in the beginning and how you want it to be displayed and evaluated.
Thank you very much. And I think that concludes the new questions that we have received. So I'm actually going to go back to some of the questions we received following Allison, your presentation. Let me just get to the right place here.
Allison, you are on double secret, double mute, so.
Yes, I'm on non-mute now, so ready when you are. Thanks.
All righty. All right, so why does DoD qualify qualitative failures with a J instead of a NJ, presumptive positive, to communicate the uncertainty of a false positive?
This is a good question. I would love actually for some of the other members to join in on answering. We do have the J flag in the module.
I don't think we've ever discussed an NJ. Whenever I read that question, I'm like, it's not something that's ever really come up in our discussions as far as when we're putting the guidelines together. It's definitely something we could and would offer. If you want to give us feedback on the guidelines, something along this line, then sure, we can have a discussion within the work group and see if that is something that's valid for other modules, not just the PFAS module.
I think that's an awesome suggestion because when the theoretical ratio isn't met in a dioxin analysis, it's considered EMPC. Try to remember what that means. Estimated maximum possible concentration, but not really a hit. Awesome suggestion.
So we'll take that back as a work group and think on it a little bit. And maybe next time you see these guidelines get updated, you'll see some discussion of an NJ.
Thank you
Hopefully
all.
not an EMPC that we can't remember what it is. Because that would drive me nuts.
I think I got it, but could have been wrong. Estimated
I
maximum
trust you got it. I have no question that you got it right, but if you expected me to remember it, no, that's not going to happen. And you know that.
All righty. We have another question here. I kind of pulled back because this is in reference to this slide specifically. Regarding slide 19, when people say AFFF, does that mean AFFF concentrate, AFFF as prepared, or an AFFF contaminated sample?
Yeah, and this was the second to last slide. So, and I'm not being very specific here either. So, yeah, I think what I really mean by this is samples that you can run through solid phase extraction and samples that you can run through serial dilution. And you know, Andrea had a great addition to a previous question discussing turbidity as a factor that could influence the choice that you have to make here, which is not related to PFAS concentration at all. And so I would approach kind of the way you're looking at the analysis of kind of breaking it into these two parts. You know, can I run it by SPE, or do I have to run it by serial dilution, and what is the QC for each?
Thank you very much. We have a question here. What are the different QC samples for groundwater versus AFFF?
Oh, yeah. So, I mean, this one actually very similar answer. So I'm giving kind of water examples here, you know, groundwater, and then presumably some sort of high concentration AFFF, like, you know, fluid example. But again, this just goes back to look at how you have to analyze the sample. Can you use SPE, or do you have to use serial dilution? And the QC is based on that.
Thank you. We have a question. Do you have any sense regarding how common an interferent masking a true PFAS hit might be?
Oh, gosh. I don't know if anyone else wants to weigh in, or if anyone even wants to weigh in on the chat, but I don't have a sense of this. You know, ideally with good chromatographic resolution where, you know, and proper analysis of, you know, the standards versus the samples, we're getting the molecules that we need to look at in the appropriate places. And, you know, we've shown you a couple examples today where, you know, it looks like a false positive and a false negative, but, you know, a lot of data we get looks just fine, of course. So I don't have a good sense of this. I guess one thing I should add is that, you know, analytes that have both branched and linear isomers do have a little bit of a larger retention time window that you look at because you have to fit both the branched and linear isomers of your standard, you know, into your analysis. And so I believe that with those, PFOS being one of them, I think PFHXS being another one, maybe if people have other favorites. But I think if you end up in a situation where you have branched and linear isomers and a bit of a broader retention window, those particular analytes might be at a, you know, higher incidence of potential interference causing, you know, interfering with the results of your true analyte.
Thank you very much for that response. For low-level samples, is a MSD required per batch or per sample?
Well, double check the DoD QSM. I believe the QSM requires per batch, but this is a great thing to discuss as a project team and to specify in your QAP, because you might have situations where you really want an MSD from your own sample, not from, say, some other clients that's in the batch, or perhaps you know you have kind of different matrices, maybe different qualities of your samples that you're submitting, and you might want your own MSD for each type of matrix you're submitting. So there are the requirements, and then on top of that, there's the project team discussions that you would want to incorporate into the QAP to most appropriately give you the information that you need for your particular analysis.
Thank you very much. What about samples that require dilution? Is it better to extract a smaller sample volume, run a straight dilution, or dilute the extract and top off the internal standards?
Oh, I don't know the answer to this one, but I'd be delighted to know. Can anyone else on the group speak to it? Or perhaps we might have some people in the chat put their favorite methods.
I believe since the whole container needs to be extracted, that dilution should happen after the extraction.
We may save this question to be answered after the meeting, send it out to our PFAS technical experts, and just get that answered for you. Let me see if we have what we have remaining. Does DoD publish quality guidance for PFAS that is applicable to drinking water matrices?
So Matthew, this is Jordan.
Yeah, go ahead.
I'll handle
Go
this.
ahead, Jordan.
No worries, Allison. So no, we require the use of the drinking water methods, 537.1, 533. That's what our requirements are.
I'd like to add that the validation guidelines can still be used. You just have to substitute the method criteria, use the flagging criteria from the module. That's the intent of the module.
Sorry, Andrew. I was going to also mention, the EPA has released validation guidelines for 537.1.
Is it your preference that that's used?
But I'm just pointing out it has the specific criteria that you mentioned.
While we're in dead silence for a minute, I did open up the validation guidelines in relation to the continuing calibration verification and showing J's being applied and UJ's being applied, unless it's a major anomaly, which we identified as, I believe, 30%. And that's when an X is applied. So if you have something that's out in comparison to something else, you don't know if your initial calibration is an error or if your continuing calibration is an error, and somebody needs to look at it more closely.
Thank you very much for that clarification. We have a question here. The DoD requirement is for the analog and sample to have retention times within 0.1 minute. But what happens if the predicted elution time is 9 minutes for PFOS with a total runtime of 20 minutes, but the run is shortened to a less than 9 minute runtime? Would DoD accept?
When
I'm not sure.
changes,
oh, go ahead.
You can go.
Yeah.
You want to go? When major changes are made to the initial calibration or the instrument, you should be running another initial calibration. You shouldn't be changing your process and then expecting to extrapolate to a new process. Stay consistent.
Yeah, I agree, and that's a great way to put it. It does, just kind of, we do have the requirements of the DoD QSM that should be met. So if it looks like they're not going to for reasons, it sounds like that communication would be key. And also what Andrea said. So thank you, Andrea.
Thank you. We have a question. Can signal-to-noise ratio also be an indicator of false positives or negatives?
I didn't cover signal-to-noise ratio in my presentation because actually the signal-to-noise ratio was good for these. So I believe there are evaluators for it. We could either circle back on that one, or if my other members remember the module off the top of their head with regards to signal-to-noise, we could discuss that now.
Yes.
I know the answer if we're talking about looking for a munition underground in a digital geophysical instrument. It's definitely yes. But that doesn't apply to PFAS. But I think the answer is yes. That was a little bit of MMRP humor if nobody got it, because we have a lot of chemists on the line. I'm sure Jordan was chuckling in the background. We argue about this every other week.
I was
We argue about signal to noise in a completely different context. When you said signal to noise, I'm like, oh no, here we go.
Yeah, I was able to get it open, and so where the specific signal to noise requirements are greater than 10-to-1 for the quantitative ion and greater than 3-to-1 for the confirmation ion. So those would be things to definitely look at as well. Yeah, thanks for the question.
Thank you very much. We have a question here. Module 3, Section 5.3.1 directs the validator to evaluate the average RFs, but does not provide any numerical guidance. Will future revisions of the guidance include numerical guidance for average RFs?
I'd say I'm trying to find the question in the text so I can catch up with the first part of it again with the sections. Matthew, I don't know if you mind.
It was at 310.
Is it specific to PFAS?
Yes, it's specific to Module 3, and this module was developed by another subgroup, so.
Matthew, why don't we answer that question offline? Why don't we go back to some folks and see if we can rally that? I think it's a good question.
No problem. Can you clarify the 100% stage 2B and 10% stage 4 is a percentage on the data received per project?
Yeah, and so like I said before, I just want to stress that this is something that I've been kind of seeing, or as a recommendation. It's not any sort of official policy. Overall, obviously, it's just kind of a project team discussion and customer discussion based on what they need for their data quality. And so, we've seen a variety of things. So you could also write it, if you would like, as 90% stage 2B, and then, the rest of the 10% is stage 4. I guess it kind of depends on how you're looking at. So basically, every piece of data that you'd be getting, in the way I wrote it, would get the stage 2B data validation, but then an additional 10% of the data would go all the way to stage 4 with the recalculation. So that's what I meant by that. And I think I wrote also every data package. That's also a project team discussion too. So for example, like would you like to see, say if you have many batches you're submitting to the laboratory and expecting many data packages over time, would you like to see, say, maybe one data package fully validated to stage 4? Or would you like to see that 10% of stage 4 come out of a variety of your data packages that you receive over the course of your project? So those are all project team considerations.
Thank you very much for your response. I believe now we can head down back to some of the questions that we received later in the presentation. This one came at 429. When should a performance evaluation sample be included? Lab validation or with the field samples?
It could occur at either, I mean, usually I think of that as coming with field samples. If you want to use it for an understanding of how the laboratory is performing on your specific project samples, it would most likely be coming in with your field samples. It could be if you had a lot of samples you need to process for a given project and you wanted to do some pre-planning with your laboratory to make sure that they're going to process effectively and deliver you data of sufficient quality, it may warrant submitting a few performance evaluation samples ahead of you ever hitting the field, just to make sure that you have all your processes in order. So make sure that, particularly if you're doing ISM type work, that you want to evaluate the drying and grinding and its impacts on potential field samples when they finally hit the door. You may want to set up a few performance evaluation samples that get processed prior to you ever going to the field.
Thank you very much for that response. We have a question here. How do you define low and high concentration samples for determining appropriate methodology?
When they came out with the serial dilution for AFFF standards to purchase and buy and use as neat stuff in the industry, they had to determine an analysis to run these neat samples. That's what they're referring to every time somebody says AFFF. However, in the field, you could have very high concentrations depending on how close you are to a source or if that neat stuff spilled. Typically, it's mixed at 5% before use. But you would need to look at probably your laboratory's initial calibration and see if they're going to be needing to run 100 times dilution to bring concentrations within the calibration range. You're starting to probably need serial dilutions.
Thank you for that response. And I believe this is our last question of the day. We have a question, we are often asked by PMs, what level of validation should we do for this project? How do we determine that?
This is a great one. So, Constantine, thank you for asking. You respond back to the PM with a question, of course, which is, what level of decision do you want to make? And then I can answer your level of validation you may be appropriate. This gets to if I'm doing long-term monitoring and I'm just trying to produce trend analysis, I may be able to live with 2A data validation as I go along, because I'm going to get another sample again next month and the following month, and if I need to up or lower my validation, I can do that as I go along. If I'm trying to make a decision that I need to do $3 million worth of remediation, and it's going to hang on a particular sample event that's going to take a month to get done, and I may have 10 different SDGs or 8260, then I may need level 4 validation on all that data so that I make sure that I make accurate decisions or a reasonable decision, I shouldn't say accurate, a reasonable decision about the $3 million cleanup I'm going to do. So I would look at it from that standpoint. What is the decision you're trying to make? Are you trying to populate a trend table, or are you trying to make the $3 million decision? Jordan, do you want to jump in?
No, I think you're right, Brian. I think it depends on the decision you're trying to make, right? I mean, this is something that the project team needs to make a determination, in the planning stages, right? To figure out what your goals are and make sure that whatever you're doing to evaluate your data is appropriate for you to be able to meet those goals.
I'd also like to point out that you should be considering receptors, and the sensitivity for PFAS right now is pretty high, and people don't want it in their water. So depending on how far inside base boundaries you are, and you're never going to be near a human being drinking anything, then you probably don't really need to be too concerned if you're just monitoring remediation. But if it's off base and it's getting into water, people are using it and it's a risk for humans. You want to be more careful about the data that's being reported. I believe AFCEC came out with a baseline for the 90-10 and for PFAS. So for AFCEC work, that's the level of validation we're doing is 90% stage 2B and 10% stage 4. I'd also like to point out that in our general module and in the modules, we do cover stage 4, and we talk about what you would select as that 10%. I often see somebody say, well, just this one sample. Sometimes you want to be focused in on a particular compound, or you want to be focused in on a particular pivotal sample location, or otherwise you can find more guidance within the modules on as far as what is 10%.
Perfect. Thank you all for your great presentations and your great responses to questions. At this time, this concludes our webinar. Brian, would you like to have any closing words?
Yeah. So let's remind you, please fill out that survey. Many of you may go, I don't want to fill out another survey, but please, when you get that survey, if you don't get it, be looking for it in your email, because it really helps the EDQW when it comes time to do the next webinar. And I'm sure we will have many more of these webinars. I think these webinars work well, even if we are able to hold an EMDQ, which I'm probably, judging by where things are with COVID, that's probably not going to happen. So Disney is probably out again this year, darn it. But we'll see, and you'll be hearing about that soon. But please fill out that survey. It helps us with understanding what the next presentation is going to be for a webinar series, as well as gives us feedback as to whether we met your needs. So please keep that in mind. And we do appreciate your attendance today and spending the time with us. Hopefully you found this very helpful. And I guess that will conclude the webinar. Thank you all.
Have a great afternoon.